In this video, let us see how we can form a partial differential equation from the given equation. So for that, we take one function that is equal to f of x, y, z equal to 0. This is one of the function. Here x and y are independent variables. That is, z is a function of x and y. So we can write z is equal to f of x comma y. The partial differential equation contains the parameters, that is dou z by dou x, dou z by dou y, dou square z by dou x square, then dou square z by dou x dou y, dou square z by dou y square. So since z is a function of x and y are independent variables, while differentiating with respect to x, y is a constant. Because this x and y are independent, when you differentiate a function with respect to x, at the same time y is a constant. When you differentiate with respect to y, then at that time x is a constant. So here the notations are, this dou z by dou x is taken as small p, and this is taken as q, and this is equal to r, this is s, this is equal to t. So these are the parameters we are using for writing a partial differential equation. So where we can use this p and q, where we can use r, s, t, etc. So if the function contains arbitrary constant. So what is arbitrary constant? Suppose the equation is of the form, then z is equal to ax plus by plus c. Here a, b, c are the arbitrary constant. So how we can form a partially differential equation? We can eliminate this a, b, c from this equation by using these parameters p, q, r, s, t. So the given function we can differentiate with respect to x, with respect to y, and with respect to the second derivative we can find it, and second derivative with respect to y, etc., etc. So where we can apply first order, where we can apply the second order. First, you check count how many arbitrary constants. Here a is an arbitrary constant, then b and c. Total number of constant is equal to 3. So number of arbitrary constant is equal to 3, and a number of independent variables. Number of independent variables, that is equal to 2. Which are the independent variables? X and y. So the equation contains 2 independent variables, as well as the equation contains 3 arbitrary constants. If the number of arbitrary constant is greater than number of independent variables, we use the second order equations. Second order equation, that is r, s, t. And if the number of arbitrary constant less than or equal to this number of independent variables, that is here 2 only. So number of independent variables less than or equal to 2, then we use the first order equation, that is p and q. So let us take one example. Z is equal to ax plus by plus ab. This is one of the equation. Here a number of arbitrary constant. equal to 2 because a, b only. And a number of independent variable equal to independent variable is 2. In your syllabus, number of independent variable is 2 only. So this is less than or equal to 2. We can use the first order equation. So first you differentiate with respect, you take this is equation number 1, differentiate partially equation number 1 with respect to x. So what is answer? Dou z by dou x is equal to a is a constant, x differentiation of x is equal to 1. Here y is a constant, so that is 0, and ab, that is a constant 0. What is dou z by dou x? The dou z by dou x is equal to p. So p is equal to a. Differentiate partially equation number 2 with respect to y. Then what is the answer? So the answer is dou z by dou y is equal to, that is 0 because x is constant, b into y differentiation is equal to 1 and 0. So our answer is q equal to b because dou z by dou x is with p and dou z by dou y is equal to q. So we can substitute. So what is the final answer? Now substitute the values of a and b. That is a is equal to p and b is equal to q in equation number 1. The answer will be z is equal to px plus qy plus pq. This equation contains no arbitrary constant. Therefore, this is our required answer.